Believe it or not, we're starting with the same question again, except now I'm asking how many bits make up the tag, set, and word. The word won't change, but from the original question, which was 1 cell per word main memory, 16-bit address, 128 kilobytes. Now the cache is not direct mapped, it's not 4-way, it's 2-way set associative. Now what that means is there's 2 lines per set. It does not mean there are 2 sets. There might be a million sets. It means there's 2 lines per set. The blocks of memory are mapped to a set. It has 2 choices. Choice is good. Well, a 2-way set associative cache should be more efficient than a 1-way set associative cache, which is called a direct mapped cache, which is simpler but slower. Now we have this least recently used algorithm. Let's take a look. Eight lines, 2 lines per set. So what really matters is set 0, set 1, set 2, set 3. So cells 0 to 31, which make up block 0, goes somewhere the least recently used place out of those 2 lines. You don't even have to write the line anymore, just the sets matter. Cells 32 to 63 go somewhere here. Cells 64 to 96, what are we going to? 64 to 95 goes somewhere there, and 95 to 127 goes somewhere there, and 128, etc. That would go start wrapping around and going back there. So if you said, where does cell 135 go? Well, it's somewhere in here in 128 to 159. So this is block 0, block 1, block 2, block 3, block 4. Cell 35 is in block 4, along with cells 128, 129, 130, etc. up to 159. That's for principal spatial locality. If you wanted cell 135, for example, from memory, I just made that up, you would bring in everything in its block 4, cells 128 to 159, and put it in the least recently used line in set 0. Block 4 goes in set 0, 1, 2, 3, 4. And then, so block 0 goes there, block 1, block 2, block 3, block 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you want to find out where something goes, where a cell goes, find out what block it's in, and then mod it by the number of lines in the cache. If I mod by 4, I get a remainder 0 to 3, which gives me exactly the scenario I want here. Mod by the number of total lines. So the question here is, how many bits make up the tag, set, and word? Well, 5 for the word. The log of this has not changed, will not change. What will change is how many sets there are. We can see there's 4 sets. 8 lines, 2 to the 3 lines, but 2 to the 2 sets. And again, there's actually more competition because you're fighting for only 4 things instead of fighting for 8 things. There'll be more bits to identify who's winning this fight. So the principle of spatial locality is right here. The width of a line, the size of a block, which is the same thing. And temporal locality is right here. Keep the most recently used things here and evict the least recently used. So 2-way set associative isn't very making great use of temporal locality, but it makes some use, and a direct map cache doesn't make any use of it. So this is more efficient than a direct map cache, probably less efficient than a 4-way or 8-way or 16-way set associative cache, where we can make 2 or 4 or 8 or 16 choices. Here we have 2 choices for two-way. Let's do some different examples in the next video.